IBESS Biodiversity Conservation Part 6 examines the relationship between diversity, stability, succession, and human activity. This is a complex concept that I've covered earlier in the course. The essential idea is, while global biodiversity is difficult to quantify, it is decreasing rapidly due to human activity. Classification of species conservation status can provide a useful tool in the conservation of biodiversity. Here is the outline for the biodiversity conservation movies. Use this slide to find the movie you need for review purposes. This movie is focused here. Here is the IB Syllabus statement that drives this movie. Discuss the link between ecosystem stability, succession, diversity, and human activity. An ecosystem's capacity to survive and change may depend on diversity, resilience, and inertia. This movie will look at succession, tropical biomes, and human activity within the theme of diversity and stability. Stability is a complex issue, and it's defined as the likelihood of an ecosystem to return to equilibrium following disturbance. There are two aspects. There's inertia, which is the ability of a system to resist disturbance, and there's resilience, the ability of a system to return to equilibrium. Let's start with succession, and I ask, does stability increase with succession? And most would argue yes, but this is a discuss action term, so let's take a look. Early successional stages have relatively low diversity and less stability. These are more susceptible to environmental fluctuations. This graph displays how diversity changes over successional time. You can see that diversity is relatively low early in succession and reaches a maximum late in succession. Grassland biomes represent a biome in an early successional stage. Grassland biomes have medium diversity, and they are easily disturbed, specifically by fire, by way of example. However, grasslands have stability in that they are resilient. They recover quickly from the disturbance. The tundra biome includes many low-growing shrub species and grasses. The tundra is dominated by mostly early successional species, and it's of relatively low diversity. Interestingly, the tundra biome is a stable alternative state, a type of climax community. But the tundra is easily disturbed, and it does not recover quickly because of the low productivity that comes with the cold temperatures and the low light conditions. Here on the right, you can see the tracks of a vehicle left in the tundra. These tracks will be apparent for years and years to come. The tundra does not recover from disturbance. Agricultural ecosystems are typically early successional stages with regular disturbance, plowing. As well, many of our agricultural systems are monocultures with low genetic and species diversity. Diversity is additionally low because of the frequent disturbance and the use of pesticides and herbicides. Relative to the native habitat, whether that be prairie or forest, the agricultural system is of low complexity with very simple food chains. The agricultural system seen in this image is not stable. Even rice paddies have low genetic and species diversity due to the monocultures along with the use of pesticides and herbicides. When we convert large tracts of land to agricultural fields, there is low habitat diversity as well. Here are images of the desert biome. Like the tundra biome, the desert biome represents a climax stage, but the desert is of low diversity and it is easily disturbed, as you can see from the tracks here and here. The system is not stable as it does not recover quickly from disturbance. The system is not resilient. So diversity does increase as succession proceeds, but keep in mind that different biomes have different climax states, some of which are not stable because they do not recover from disturbance. The climax stages of deserts and tundra are not stable. So late successional stages in forests, locations with high NPP due to warm, wet, abiotic conditions, are more diverse. Habitat diversity is high due to the foliage height diversity, And foliage height diversity increases the number of niches. Overall, this increases the diversity of the system. So I'm working to discuss the stability and resilience in a variety of systems. The resilience of a system, ecological or social, refers to its tendency to avoid tipping points and maintain stability. Diversity and the size of storages contribute to stability and affect the speed of response to change. Humans can affect the resilience of systems by reducing those storages, think of deforestation, reducing diversity. So, with a focus on how succession is related to stability and diversity, here's an argument for an increase in stability as succession proceeds. One, there's a greater constancy of the physical environment and greater diversity of species in late succession. There are more interlinked food webs that might be better able to resist changes late in succession. There is greater structural heterogeneity in a climax community. Again, late succession. We have floor species, substory species, and canopy species. We have long-lived species late in succession, and these long-lived species, trees, increase the stability. There's less fluctuation in the population late in succession. Climax stages of forest ecosystems are stable. They have inertia, persistence over time, because of these huge trees, which are large storages, perennials that persist in time and are difficult to disturb. But these forests, late in succession, have low resilience. If they are disturbed, they reach a tipping point, and they do not easily return to the original equilibrium. As we discuss forests and diversity, let's examine the relative value of tropical forests in contributing to global biodiversity and global ecological services. Tropical forests are symbols of high diversity, ecosystem services, and green politics. Ecosystem services result from intact ecosystems, undisturbed ecosystems. Services include reducing soil erosion, the purification of water as it infiltrates the ground, the transpiration of water vapor into the air, and the uptake of carbon dioxide, reducing atmospheric CO2, reducing greenhouse gases. Rainforests have habitat diversity in terrestrial and aquatic habitats, not to mention the various canopy layers. Rainforests are complex ecosystems with varied nutrient and energy pathways which contribute to its stability. Recognize that vast tracts of rainforest remain because they are located in less economically developed countries where development has been historically slow. But being located in a less economically developed country is a source of vulnerability going forward. Stay tuned. Rainforests have high global biodiversity, in part because the foliage height diversity creates many niches. The complex ecosystem, like the rainforest, has variety in the nutrient and energy pathways, and this contributes to its stability. Tropical forests are warm and wet, with high sunshine, high insolation, and historically they've been unglaciated, thus have been undisturbed, allowing their complexity to develop. Rainforests have high habitat diversity with forest, river, and many leaf layers beneath the canopy. A complex ecosystem like the rainforest has variety in the nutrient and energy pathways, complex food webs, and this contributes to stability. Rainforests are mostly located along the equator within the tropics. Vast areas of rainforest remain because of their location in less economically developed countries, but this makes rainforests vulnerable because populations of less economically developed countries are growing and protection of the forests is weak. The high diversity of rainforests has been studied in an effort to understand its origin. The energy stability area theory has been proposed. High solar energy, stable climate, and a large area. And add to that habitat diversity, foliage height diversity, high productivity, and low disturbance over long periods of time. Again, the high diversity of equatorial rainforests comes as a result of the large tracts of land, the complex energy pathways, complex food webs, historically low levels of disturbance, unglaciated over long periods of time, and high net primary productivity. They are vulnerable, though, because many of rainforests are located in less economically developed countries where protection of the forests are weak and populations are growing rapidly. High productivity, but the productivity takes time to regenerate. They don't bounce back from disturbance. Rainforests have persistence in time, inertia. Rainforests are difficult to disturb. They display stability. The trees of the forest are perennials. They are long-lived, thus stable. There are high levels of interdependence, mutualism, thus stable. Constancy in the physical environment, thus stable. In equatorial forests, where there are warm temperatures year-round and high light levels year-round, there is a constancy to the physical environment, thus stability. Rainforests have complex food webs, many interconnected links. The soil community is developed, well developed. Nutrient cycles are closed. So here are 3 IB syllabus statements that you should be able to handle. Explain how a greater habitat diversity leads to greater species and genetic diversity. In a complex ecosystem, the variety of nutrient and energy pathways contributes to its stability. An ecosystem's capacity to survive, change, may depend on its diversity and resilience. Continuing with the discussion about how rainforests have relative value in contributing to global biodiversity, this diagram shows diversity of bird species and latitude. At high latitudes, the diversity is low, but as you proceed to the equator, diversity increases. So this brings us to 2 IB syllabus statements. The first, quantification of biodiversity, is important to conservation efforts so that areas of high biodiversity may be identified, explored, and appropriate conservation put in place where possible. Discuss the usefulness of providing numerical values of diversity to understanding the nature of biological communities and the conservation of biodiversity. Quantifying biodiversity allows diverse areas to be identified, explored, and possibly conserved. Here is a graph that displays the diversity of lizard species with latitude, and you can see that as you get closer to the equator, the higher the number of lizard species, the higher the species richness. Tropical regions with their high diversity require conservation. If we can quantify diversity, evidence exists for the protection of the forest. Numerical values of diversity are useful in understanding the nature of biological communities so that appropriate conservation can be implemented. Forest trees are very large perennials, huge storages that resist disturbance, high inertia. But when trees like this are cut, the system does not bounce back. Climax forests have low resilience. Remember, diversity and the size of storages contribute to stability, and they affect the speed of response to change. The size of the storages in rainforests are huge. Thus, the response to disturbance is slow. But if the tipping point is reached and the forests are cut, they do not easily return to equilibrium. In slides to come, I will strengthen the influence of human activity in the discussion of succession, diversity, and stability. These 2 IB syllabus statements, which I've already shown you, bring human activity squarely to the middle of the discussion on succession, diversity, and stability. Discuss the perceived vulnerability of tropical rainforests, the relative value in contributing to global biodiversity and global ecological services. Evaluate the impact of human activity on the biodiversity of tropical biomes. Most tropical biomes occur in less economically developed countries, and therefore there is conflict between exploitation, sustainable development, and conservation. In less economically developed countries, resources are exploited. They're exploited because they lift the welfare of the people. The priority is on economic growth, not conservation. Modest monetary resources are available to protect natural resources. Law or enforcement of law is not strong, and there's high population growth, thus increased pressure on the resources. Tropical biomes contain some of the most globally biodiverse areas, and their unsustainable exploitation results in massive losses in biodiversity and losses in the ability to perform global ecological services such as the transpiration of water, the filtration of water into the soil, or the exchange of gases with the atmosphere. Rainforests are vulnerable to population growth where slash and burn farmers would burn a forest to clear the way for agriculture for food production. As well, the high productivity of rainforests has resulted in trees of great proportion, a resource wanted by people for their needs. This creates conflict between exploitation and sustainable development in tropical biomes. Adding to the vulnerability of rainforests, less economically developed countries tend to have less regulation. The laws are less well enforced, thus higher rates of illegal deforestation occur. Deforestation and burning reduces diversity and reduces the ecological services provided by forests. The services such as the uptake of carbon dioxide, the transpiration of water, and allowing groundwater storages to recharge are all lost when forests are cut. In this diagram, you can see the areas in red that have been deforested. When poor people need to grow food or economies of the world demand the resources of the forest, there will be conflict between exploitation and sustainable development. Diverse forests are replaced with monocultures, in this case, sugarcane. Again, conflict between exploitation and sustainable development. Is the reduction of diversity or the simplification of the system sustainable? No, the simplified system is less stable. Agriculture simplifies ecosystems, resulting in less diversity. Again, conflict between exploitation and sustainable development. Reducing the diversity of the system makes the system less stable. In this slide, you can see the deforestation of Borneo over time. Deforestation reduces diversity, reduces the ecological services provided by forests. Ecological services can only be provided by an intact, undisturbed system. Services include evapotranspiration, climate regulation by taking up carbon dioxide, water holding capacity of the soil, water purification as water infiltrates groundwater storages. Again, there's conflict between exploitation and sustainable development. Is reducing system services maintaining a sustainable system? No. Is the system less stable as a result of reducing the natural services provided in the intact system? Yes. Human impact in tropical forests can be seen in these images and characterized as short-term gain, long-term damage. Again, you can see the conflict between exploitation and sustainable development. So I've been drilling in on this IB syllabus statement, discuss the conflict between exploitation, sustainable development, and conservation in tropical biomes. Hopefully, you have reasonable control of this. But let's continue with the idea of sustainable development and conservation. Tourism puts pressure on tropical ecosystems. While these images are attractive, consider the ecological damage of tourism. Could this be the location of a new tourist resort? Remember, if the forests are cut, they do not recover, resilience is low. They are pushed to a tipping point, pushed to a new equilibrium, and they don't bounce back. I've had these three statements before you earlier in the movie. Can you now see the application of this statement? Humans can affect the resilience of systems by reducing storages and diversity. As well, you should recognize that the size of storages, such as the large trees of a late successional stage forest, contribute to stability. Rainforests have large storages, so the speed of response to disturbance is slow. And while rainforests are stable due to those large storages, once disturbed, the resilience is low and the system is pushed to a tipping point. Tropical forests are not resilient. The forests do not bounce back to their original form once cut. The diversity is less after deforestation has happened. The system has been pushed to a tipping point. This IB syllabus statement has been the singular focus of this movie. So let me bring this movie to a close by bearing down on the activities of people that simplify systems, disturb systems. I'm asking you to discuss the link between ecosystem stability, succession, diversity, and human activity. Slash and burn farmers remove forests to grow crops, a change from late successional forests to early successional grasslands. Diversity declines. Within a short period of time, soil fertility declines, forcing the farmers to move to a new location and start again. Industrial exploitation of forests also occurs as the resources of forests are in high demand by the economies of the world. Human activities simplify ecosystems by increasing disturbance and reducing stability. Remember that when forests are cut, secondary succession starts anew. Humans simplify ecosystems through agriculture by growing a single crop, a monoculture, along with regular plowing and pesticides and herbicides. Agriculture maintains a relatively early stage of succession. The simplified system is less diverse and less stable than the original ecosystem. Even agricultural systems in less economically developed countries are simplified systems, less diverse and less stable than the original ecosystem. Industrial agriculture maintains systems in an early stage of succession with regular disturbance. The system is nothing like the original ecosystem. Human activities influence succession. Agricultural systems maintain community growth at an early successional stage. Species such as annuals are the colonizers, and regular plowing is a regular form of disturbance, all in an attempt to increase net primary productivity. Net primary productivity is relatively high during early succession. And that brings us to the end of IB ESS Biodiversity Conservation, Part 6.